review. Today, the video, as you can see, is titled DHCP server configuration on routers. For those of you in America, you call it routers. I'm in England, we call it routers. And however you pronounce it, they are one and the same thing. So on the right hand side, you see a subnet I call subnet2.com, and I have a DHCP server which sits here. And on the left hand side, I've got a DNS server and I've got a DHCP relay agent. We will get to what that means in a moment. And I've got a machine here which supposedly has an IP address of .51 of this subnet. And I have another machine here supposedly have an IP address of .101, and this UCM server has an IP address of .5. This has an IP address of .20. I do have connectivity between these two routers or routers. Let's head over and have a quick look for a moment. So I had it open earlier. So router 2 on my left hand side and 1 on my right hand side. Now the IP address is .1 for router 2. The IP address is .2. I think that is the other way around. So just show IP interface brief, because router 2 is 2. Move that across and just mislabeling 2, and then confirm that, show IP interface brief. Okay, it says it's up and up, but a quicker way to do that is you can do show interface and you can do a summary, and when you see a star it tells you that the interface is up and up. Okay, so type in show interface brief. IP interface brief is looking at up and up here. You can go down here and do show interface summary, and you can see that's up. Okay, so let's find out. This is up and up and up. Ping 10.10.10.1, which is the other side. And I saw a receipt, and it's finished because it's not pinging successively, so it's just one ping. Okay, so that's up. For good measure, let's do ping 10.10.10.2. okay, ping 10.10.10.2, and we have connectivity. However, from router 1 here, there's a DNS server which is going to be part of my DHCP scope. Can I get to it? Ping 172.16.1.20, and it says no, I cannot get to it. But can I ping this UC server which is on my side? So router 1 is on this side, so you can see that. Can I ping the UC server on the side which is 172.16.2 and .5? Ping 172.16.2 and .5. Ha! 2 pings, guys, and it says nada. Okay, so this is what we're going to do first. I will leave you to find out why this is not working in a moment, and I know some of you already know, which is great. I'm not going to show it around yet, but let's go ahead and configure our DHCP server. Our DHCP server is router 1 or router 1, and these are the information we have here. We are excluding these IP addresses in this subnet and IP range, and we're excluding these IP addresses in this subnet and IP range. Now, before we do this, let's explain a little bit why we have the DHCP server on one side and not on both sides. In the olden days, maybe a long time before you and I were born, we used to have a lot of switches everywhere and different brokers domains everywhere, and we didn't have the intelligence in those days to spin up one server and stick it in the data center and be able to get a DHCP server to supply DHCP scopes or IP addresses to all machines which are on different subnets. But Cisco and all those big clever guys came up with an idea of getting a DHCP server which could sit anywhere on the network, be the one that serves IP addressing for the whole network. So you see Microsoft DHCP servers are very popular, but of course Cisco makes it possible, and other vendors like HP now just make it possible for you to create your own DHCP scopes even on their routers. Okay, in enterprise you find that it's mostly done on servers, which is shaped like this. But today we're going to do that on a Cisco router here, as you can see. So for one scope, which will serve this 172.16.1.0/24 network, we'll have DHCP scope excluding 1 to 50. So I suspect the first machine to be 51, and then this one would exclude 1 to 100, and I expect the first machine to be 101. The least it will get to be 101. So this is all just speculated, but of course once it's working we will see if that works fine. So I have connectivity between these two different network segments, router 2 and router 1. Router 2 is a relay agent, and like I said from before, a relay agent says I don't have the ability to be the DHCP server. The DHCP server is somewhere, I know where it is, but because this is layer 3 and I cannot forward brokers along, I'll convert the request from these devices which are looking for an IP address, for example like this one here. I'll convert the request into a unicast, which is understood by routing or layer 3 devices, and this DHCP would give an address back in that way, which will now be converted into a broadcast response to this device here, which is going through the DORA process. Find out what DORA process is, DORA. You can look that up later. Okay, so it's a process that's a device which appears on the network uses to get an IP address. For the sake of time, do much more research into that, but by the time I'm done with this, you'll appreciate this more. Okay, let's go to router 1, like I said from before. And on router 1, let's zoom up a bit more. What I need to do is I need to exclude some addresses. Let's find out what I'm excluding. I think I need to zoom out a bit more. Zoom out a bit more and zoom out a bit more. So don't forget, it's DHCP server configuration on a router or on routers or routers, however it works for you. So over here, the first thing I need to do is I need to go into the global configuration mode, configure terminal or config T, and in this mode I would first start with IP DHCP, and I'm excluding the address 172.16.1.1, and you don't put a 2 here like that, no, you just leave a space in there and then you type 172.16.1 and then I'm doing .50. And on the other side here, they also want a scope to be excluded, so 172.16.2.1 to 100. So I'll do the same one here, and I'll make this 100, and I'll make this 2, and it is 1 and 2. So I've created my exclusions. Why do we create exclusions? Because you could have servers which will sit in here, and you don't want any device to get an IP address to the server, which will cause conflicts in network and of course performance issues. So this UCM server is .5 of 172.16.2. 16.0 network. So 116.2.5 is that server, and that is in this range 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 to the 100. So it falls within this range. So you can stick a lot of servers, printers, whatever doesn't need to change, like a user machine, you can stick it in there with fixed or static IP addressing, and that would save you from having to worry about conflicts of IP address on the network, and will save you performance issues. So make sure that you always exclude where necessary, and then do it from there. So now that we've done that, why don't we go ahead and create this subnet, which is on the router 2 side, and then we do the subnet on the IP addressing or scope for the subnets on router 1 side. Okay, so I'm going to go ahead and do 16.1 network, which is this one here. So to do that, what you would do is you give it a scope name. So I would go ahead and call it IP. The command is IP DHCP, and of course it says DHCP, but then you have to go pool, and then I called it subnet 16.1.0. Why 16.1.0? Because it's 16.1.0 network, which is 16.1.0 network here, so 16.1.0. And then I'll say the network I'm covering for the 16.1.0 is 172.16.1, of course the 0 network, and it's a /24, so 255.255.255.0. Now, machines need DNS to resolve IP addressing or resolve names to IP addressing. So my DNS server, you just type DNS server, and it's 172.16.1, and it was .20, okay, which still falls within that 1 and .50 exclusive ranges. So .20. Then I'll say my default router is, and default router is your gateway to your gateway to the network, yeah. And I'm using default router 1.1. Beautiful. And the lease, the lease over here says 0 days, 20 hours, and 30 minutes. So 0 days, 20 hours, and 30 minutes. So the lease is going to be 0, 20, and 30. 0 days, 20 hours, and 30 minutes. And all you do is press enter. Create a domain, and my domain name, I've called it subnet1.com. Okay, and then if, for example, I had a TFTP server somewhere, I could use the command nest server, and maybe we should just put one there for good measure, 172.16, and let's take that one over the 1 subnet area. So let's do 1, and then let's do .10, and that could be your TFTP server if you had one. So the same thing we've done now, we're going to do the same thing for the other subnet, which is subnet 16.20. So again, IP DHCP. Yes, I need to get out again. Comp T IP DHCP. Cool. And the name is, and I called it subnet 16.20. The network for that subnet pool is network is 172.16.2.0, 255.255.255.0. Okay, it covers that big network. Was just 252 devices really available, 254 really. and the DNS server, it's 172.16.1, not 2, and 20, because that's a DNS server over here. The 20. So I'll do that and immediately go into default route, and mine is 172.16.2.1, and worry about my lease. Now the lease I have here says it's 1 day, 5 hours, 7 minutes. So the lease is 157. It's pretty, that's simple. And I'm not worried about the TFTP server here, but I can stick it in for good measure. So net server 172.16, and I decided to put it in the 1, and it was 1.10. Okay. Copy run start. So I've configured my DHCP server, and because I've configured my DHCP server, I can do show IP DHCP, and let's look what's available. I can see the pool, and it gives me 71600, it gives me 71620, gives me 1 to 254, 1 to 254, and it tells me total address is 254. And then if I want to see if there's any device that's trying to get an IP address and when the lease expires, there's none at the moment because it's not enabled to do that yet. Okay, so what I need to do now is this interface fast Ethernet 10 over here. I will put my IP helper on that interface. IP helper on that interface. Now, is that correct? Is it really what you want to do? If I do have the DHCP server sitting here, do I need to put the IP helper here? Well, let's find out. Because this interface is here, but then this is the router. There's an interface, and every interface depicts a subnet. Okay, so that subnet needs to know how to get to a DHCP server and give the lease across. So I'll leave this there for now, and if you don't need it, we'll take it off. But I want you to get thinking about how this works. So let's head over again and let's configure this interfaces to do what it's supposed to do. So router 1, show IP interface brief, include up. So fast Ethernet 00 has that. Show run interface fast Ethernet 0, and I have this IP address there. Conft interface fast Ethernet 0/0. IP helper. But who is my DHCP server? My DHCP server really is the same router. What's the IP address of this router? What are we going for? Okay, so the IP address of this router is going to be an interesting one. Are we going to use 10.10.10.1 or the interface IP addressing for F1/0? It's good for you and I to think about it. So let's, for example, say we're going to use 10.10.10.1 and copy, run, start. Uh-oh. No. Something went wrong. Yes, wrong interface. Let's crash that. Go back. So interface No IP helper. Come see the interface facing that subnet is F0 not description. Yeah, F1/0, guys. It's good to pay attention to that, okay? So you don't trip over. So of course I've not done a good job now. So conf t interface F1/0 description downlink to subnet 1620. Okay, IP address 172.16.2.1 255.255.255.0. No shut IP helper 10.10.10.1. Bring 172.16.2. I want to see if I can get to any of these networks devices here. Alright, so 172.16.2 and .5. Can I get to it? And yes, I can. So that ECM server should be able to get to that gateway. Can I ping 101? Is 101 alive yet? Is it 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 alive yet? And it's not. Why? Let's find out. If I do IP, there's nothing there. But why don't I create an IP for DHCP? So IP and DHCP. Let's see, it's doing the DORA process. Ta-da! We got an IP address, and the IP address is, like I predicted, 172.16.2.101, and the gateway is that indeed. So that works. So you put IP helper here, and you specify the IP address of the router, and I've specified the 10.10.10.1. So what we need to do now is go over to the other side on router 2 and see if we can do the same over there. So router 2, conf t do show run interface F1/0, and there's nothing there. So interface F1/0 description downlink to subnet 1610. IP address, which is the default router, it's 172.16.1.1 255.255.255.0. No shut. IP helper address is 10.10.10. What do we do? Who's the one? Let's have a look. 10.10 is this one, so .1, just like the other one. Okay, and copy, run, start. Now, can I ping 172.16.1.20, which is a DNS server? I can ping that, alright. Now, this guy got to DHCP earlier. I got an address. Can we check what it has so far. So if I do show IP, DNS is there, but can we ping the DNS? Ping 172.16.1. You guessed it, 20. And still we can't reach it. Say destination host unreachable. Why? I will explain why in a moment. But let's just do this side as well. Let's configure this bit here. So now show DHCP binding. Oh, sorry, show IP DHCP binding. And I already see that one. Okay, 101, which is that guy over there. And now I need to see 51 in the subnet. Okay. So I'll go over here and I'll console in. Now when I do show IP, it's empty. So I do IP DHCP and let's see what happens here. I'm going to see if this traffic is trying to go across here. Trying to run Wireshark over here, but okay. Alright, so Wireshark will tell us if this device is starting to look for an IP address, okay, the moment I press enter. So leave that running here for now, okay, and it's PC3. So the moment I press enter, let's put over here for a second. Keep an eye out on this Wireshark, okay. When I press enter, in fact, I need to run another one here because the traffic is going to go across here. Okay. Start capture. All right. Alright, so 1, 2, 3. It's doing the DORA, DHCP. Somebody's asking for an IP address. The discovery is going on. Somebody's asking for an IP address. It's coming from this network, 172.16, from that gateway here. There's nothing that's got in there. There is some, but it's not giving any. It's getting nothing. Yeah. So this guy is still asking. He's been asking. Hasn't been given any IP address yet. So it's asking the destination 10.10.1. And did the device get an IP address? Show IP. No joy. So you see all these zeros here. Yeah. These are the zeros that you find. You don't get any IP address at all, so you don't see it over here. So something has gone wrong. What has gone wrong? Well, it's not something that's gone wrong. It's something that's been configured from the beginning. But I thought I would leave you guys to find out. So what I'm going to do is I'm going to fix this problem. Have you guessed what it is really? Are you still thinking about it? Okay, so I'll tell you what it is. we have an interlink between these two routers. This has a link into the subnet, and this has a link to the subnet over here, as you can see. So interlink, link to the subnet here, and interlink again, and link to the subnet here. Okay, but this router doesn't know, this network doesn't know how to get here, and this doesn't know how to get there. So for you to be able to request an IP address using IP helper, you need to establish connectivity that gets you there to that server for DHCP. Now, having a connectivity this way, it's good, but it's not enough, because he needs to know about how to get to this subnet if it's sending traffic back. Okay, so it's all good that you're sending traffic across this way, but if he needs to send traffic back, like we saw on oil shacks, on the wire shack, you know, the requests are going across, but if this guy is responding back, who is it taking it to? How does it get it back? It doesn't know how to get back. So this is what we're going to do. We're going to say on router 1, okay, IP come to IP route to the 172.16.1.0 255.255.255 network 0. Go via, I can say go via an interface, or I can say go by 10.10.10.2 and copy, run, start. Now when I do show IP DHCP branding, did you see that? Immediately I did that. This now has an IP address. Can I ping that IP address? Ping 172.16.1.51. Let's see. So it's attempting to go there, and the Wireshark will reveal that to us. Another one, the other one. So that replies there, but then this is not responding. Why? Because when you create a route saying to get to this network, go through this guy, you need to also create a route saying, and whenever this guy is responding, please go use this guy as my way to that network. So who knows about this network? This guy knows about this network here. This guy knows about that network there. So you need to tell this router to get to this network, please go via my friend here. Alright. So router 2, let's get to router 2. And conf t, and I'll say IP route to 172.16.2.0 255.255.255.0 network. Please go via 10.10.10.1. And I'll do copy, run, start. And once it's done, let's go back and do our pings from where we were earlier. So at first you saw it said 0, nothing is happening. Now let's ping that again and wait and see what happens. One more time. Okay, if I can get to the device, can I get to his gateway? So ping that. I can get to the gateway. So why can I not get to the device? So sometimes with GNS3 the device could fail. So let's ping something else. We made a DNS at 20. We can't get at the DNS either. Oh, we can. Yeah, so the device has issues. Okay, so it was 50. Oh, hang on, what have I been typing so far? 51. Okay, has the IP address changed maybe? So let's check again. It's PC3. So show IP. Okay, so this is interesting. Okay, perfect. This is a very good exercise. So when you looked at router 1 and we just said show IP DHCP binding, at first it showed the 51, but it tried to send it across, but because there was no route at all, it released it. Okay, so now let me make this guy look for it again. Press enter. Let us do it DORA. Let's see what we get. And it gets 52 now. When I do 52, can we get to it now? Did you see that? Yeah, so that's how it works. Okay, so always create your routes. Of course, we're going to change that now to 52 because it's 52 now. Always create your route. So this network knows about that, and this network knows about that. Now the DNS can sit anywhere, as long as you put the information in the configuration. And let's have a look again at the configuration on router 1, so you can take a screenshot of it, or save this video, or share this video, whatever you want to do. You feel free to do that. And it's router 1. So Cisco has this command: show run section IP DHCP. So that's the whole configuration for the DHCP, as you can see here. And copy that across. Copy that. And I'm going to stick that in here. Let's make it a little bigger. So that's the configuration over there. Okay, so IP helper on the interface that's facing the subnet you want to get an IP address for from the DHCP server. IP helper on that interface. Now, some other vendors like HP, you will not be able to give an IP address to the interfaces. So what you do is you create a VLAN in between these two, and you put IP helper another VLAN, same way here. Okay, so I hope you've learned a lot today. So a broker's domain in those days would have a DHCP server which could serve them, but Microsoft and Cisco and all those big boys decided to put together a mechanism to get the DHCP server centralized somewhere, but yet devices anywhere else could request for an IP address using a DORA, the DHCP process in getting an IP addressing, which is a broadcast. But then these routers are converted to unicast, get the IP address, bring it back, and send it back to the device which asks for it. Like you saw earlier, when I checked the show IP DHCP binding, it showed that there was an address that attempted to go out, and that was the address that I had speculated that it would be, but in the end you saw that because it could not get to that network, it dropped that route. Okay, and so it's very important that you make sure that there is a route existing between the two networks. Okay, and that helps a lot. So I hope this has been good for you. I'll see you on the next one, but before you go, why don't you look at one more a few DHCP verifications. I think one more will do. So to do that, just do show IP DHCP question mark, and I see relay and see what it says. It says relay and information, trusted sources. There's nothing there. For the information, is there anything? You barely use this command. So what you really need is this. You will look at anything that is least now. See if there is any conflict at all. There's no conflict detected now. Should we cause a conflict and see what we get here? Maybe it would be good for us to do that before we end the video. So I'll head over here, go down here. The D was set all the way there, but I want to see if we can pick a conflict from here. So come back here and alright, so let's go 52. So if I do IP 172.1.52/24, 172.16.1.1, and I press enter. Okay, this actually says there's a duplicate IP address, okay, because it knows that there is a detection of an IP address that's in there. When I go to over here and I do that, because the device does not allow me to configure it at all, so it doesn't show it here. But if it did, if I turn the other one off, for example, and I was able to put this IP address on, then you see the conflict detection over here. So the commands are not many. Show IP DHCP, and you can look at the binding, which is what you use the most. You can look at DHCP server statistics. So received, memory usage, if it's necessary, DHCP office, DHCP acknowledgement, and then boot replies, what have you. So, but I would always use DHCP binding, DHCP conflict. That's all. Okay, so thanks so much for watching, and I'll see you on the next video. Now, this lab, I've created an appliance which you can use and import into Genius 3, which you can go and do import portable projects. I will stick the location of that appliance in the description below, so you can go download this full and practice your DHCP however much you want. Wireshark is a very good tool. It helps for you to see what's happening on the network, and earlier on when I did a DHCP offer, you can see it breaks it down. Okay, so what frame we've received, it sent a broadcast to all Fs saying, hey guys, I'm here, I need an IP address. Okay, and then it just sent it to everyone there. Okay, and it didn't have an IP address, it was all zeros, sent it to everyone here. And then so that went to the DHCP server, which actually sits on the other side. And the DHCP server said, okay, you know what, that's okay. If you want to come along, that's fine. Now, why don't we watch a live one? Let me stop this one here and close and quit without saving. This one definitely is going to give me what's happening, because it sits very close to where the D server sits. So I'm gonna, in fact, let's stop that and close that, quit without saving. Start capture. Start capture. Alright. And now finally, let's just go ahead and give this guy an IP address. So he's PC2. But we're not going to give an IP address because we want to give it an IP address. We're going to go and issue a DHCP. So I want the Wireshark so yeah, so let's go. Alright, so keep an eye. IP DHCP, and there you go already. Yeah, and it got an IP address of 53. There it is. And let's go back to where that one and break it down a bit more. So it made a request to its gateway to 10.10.10.1, which is IP alpha. 10.10.1 received the 53 to give it back. So that's it. It source, its destination. It didn't know where it was going from before anyway. This came back with an IP address 16.1.253. And when I go to router 1 and I look at my bindings, we have the 3. Yeah, so this is really helpful. So enjoy. The lab will be available in the description. Download, have fun, let me know what you've done with it actually. And I thank you for viewing, and I'll see you on the next one. Have a good one.